Okay, so today we're gonna start on 2.4 or finish 2.4, which is a pretty nice section, especially using the homework because it has a bunch of graphing tools for you. So I just wanted to talk to you guys about something from 2.3 that I do not believe I covered. I wanted to talk to you about the average rate of change of a function. So here it says that the slope of the secant line represents the average rate of change of a function from A to B. So what that means is if we want to know how much a function is changing from here to here, let's say, we take the secant line and the secant line would average that change in the function. Okay, so again, we're averaging it out. We're not finding the instantaneous rate of change. Like if you wanted to know right here, we would need a tangent line, right? We would need a tangent line to draw. So what we're finding is the average, oops, it's not what I want. So what we're finding is the average rate of change from A to B, not the instantaneous rate of change. So in order to find the average rate of change, what I did is I said, well, if this is my A and this is my B, these are the two values of my X coordinates, then if I wanted to know those heights, I would simply have F of A and F of B, right? So all I'm doing is I'm calculating the heights by plugging A into F. Now, the thing is, we don't actually know what F of X is, so we just call it F of A for that height and F of B for that height. And, you know, all I'm doing, you guys, is I'm kind of looking over here and I'm looking here to make sure I'm getting the right heights. And you guys know that if you ever want to find the slope of a line, you just need 2 points. So this point is actually B comma F of B, right? That's that point. And then this point right here is A comma F of A. And again, we don't know what F of A is, we don't know what A is, but we know that whatever that point is, that's how we could represent it. So all I did is our old school slope formula, which is M equals Y2 minus Y1 all over X2 minus X1. So this formula and that formula are the same. But when we don't know Y1 or Y2, we use F of A and F of B to find those, all right? So that allows us to do something called the slope of the secant line, but we know the slope of the secant line is equivalent to the average rate of change or the slope. Oh, actually, I should write this maybe a little different. Let's call this average. Yeah, you know what? I like M average. I like that. M average. Let's do that. Okay, so here's a problem that you'll see in the homework. It says find the average value of the function for g of x equals negative 2x squared plus 4x minus 3 from negative 2 to 1. So you have some parabola. We know that this is some parabola. We don't know exactly what it looks like, but let's just say it's like the, ooh, it's negative. So yeah, it's definitely like this, right? It's downward facing. And they want to know from negative 2. So let's say here's negative 2 to 1. And again, I'm just making this up. I have no idea if this is the actual formula. I don't feel like going through and graphing it on my calculator, but the idea is that we're looking for that secant line, okay? So what I'm going to do is find that slope by doing M secant or M average, and that's going to be F of B. Well, you know what? We'll do this. We'll do F of, and this means from negative 2 to 1. So sometimes you'll see it written like that instead. So that will be F of B minus F of A all over B minus A. Okay. So when I plug 1, or I guess it's not F, it's G. Sorry about that, you guys. So let's do G of 1 minus G of 2. Okay, sorry about that. So then we're going to take 1 and plug it in, and we're going to get negative 2 plus 4 minus 3. So that is G of 1. So now we got to do F of B minus F of, or G of A, which would be negative 2 squared is 4 times 2 is negative 8, minus 8 minus 3 all over 1 plus 2. So when we clean this up, this is going to be what? Negative 1, what is that? Minus 19 plus 19 all over 3. So this will become 18 over 3, which is 6. So we have that M average is equal to 6. Okay, so that's how you could find the average rate of change. Now, what if they ask, find the equation of the secant line at the points -2, comma, f of -2 and 1, comma, f of 1. I keep writing f when it's g. I'm sorry about that. Okay, so basically they want to know the equation of the secant line. You guys remember from your previous classes, if you ever want to find the equation of a line, all you do is you do y minus y1 equals m times x minus x1, right? So all I need to do is I need to find my x and my y. Okay, and I only need 1 point. So we know that we're going to do y minus y1. So what did we say y1 was? Well, let's plug 1 in. For this one right here, y1 was this, or g1, I should say. So then that means that I believe we got -1. So when we use 1, it spits out 1, okay? It spits out -1, sorry about that. So that means we're going to be using the point 1, comma, -1. And again, I got that from here and from here. From here, okay? So that means I do y minus a -1 is equal to m, but we said m was 6 times x minus 1. So this will become y plus 1 equals 6x minus 6. Subtract 1, subtract 1. So we have y equals 6x minus 7. Okay, so that would be the equation of our secant line. Okay, so this is something else that they might follow up with you in the homework. This is a formula you guys should already know. If you have not, make sure that you ask me about it, where everything comes from. But yeah, this is something you should have learned in algebra when you were taught how to do lines. All right, you guys, that's going to do it for this. Let's move on to the next part of 2.4. Now, 2.4 is going to be the library of functions. Okay, so we're going to talk about the library of functions. Oops. And piecewise defined functions. Okay, so when we deal with the library of functions, basically they want you to know when you see something. So let's say that you see y equals x. You're supposed to know what type of function that is. When you see y equals x squared, you're supposed to know what type of function that is. When you see y equals x cubed, you're supposed to know what type of function that is. So this is what the library of functions does, is it gives you a background on what these functions are and some information about them. When you see y equals the square root of x, when we see y equals the cube root of x, let's see what else we got. Y equals 1 over x. Oops, let me move this a little bit farther. And I got one more. Y equals the absolute value of x. Let's see what else we got. Do we have the greatest integer function? I don't see it. Okay, yeah, so there's also this one. This one has a special name. They call this the greatest integer function. We'll talk about that. And then we also have piecewise. So I'll talk about piecewise separately, okay? So we just want a little bit of information about all of this stuff. And again, you guys can graph these on your calculator. So in a way, some of this learning of the, or memorizing the library of functions is a little bit lost because with the development of technology, if you ever don't know one of these, you can just put these in the graphing calculator, okay? So if we're dealing with y equals x, we obviously know this is linear, right? That's the line y equals x. It's gonna look something like this, right? And it'll go right through the, you know, maybe I should draw it like this. just so we kind of have a way to look at it. So here's y equals x going through the origin. This is a linear function. You guys obviously know the domain and range would be from negative infinity to positive infinity. X and y intercepts are pretty easy to find. You just set x equals 0 to find the y intercept and let y equals 0 to find the x intercept. And again, this is just something that you can plug in your calculator. This is a parabola. And you guys should know that this looks like this function. And again, there's a little bit of symmetry. We know this is kind of the base even function, the one that we always think of in our mind. We can fold it over the y-axis. The domain is negative infinity to positive infinity. However, the range is whatever the minimum value or the maximum value is. We'll talk more about that in chapter 3. But it's important that you know whenever you see something that's squared, more than likely you're dealing with a parabola, or oftentimes referred to as a quadratic function. When we see the cubic, you guys should know the moment you see a cubic that it does something like this. This is the cubic function. Okay, and it takes on that shape. I drew it really bad, but you get the general idea. Let me see if I can draw it better. Oh no, that's worse. Well, that's about as good as I can get. So the cubic function basically grows very rapidly. The further out x becomes, or the bigger x becomes, it grows much more rapid. And it also decreases very quickly if x becomes a negative number, then it becomes more and more negative. So we're okay on that. Now, when we come over here, this is called the square root function. And then this one kind of, I've heard some people say it looks like an eyebrow. That's basically the gist of it right here. They kind of just say it looks like an eyebrow, whatever helps you memorize it. But it's good that when you see a square root function that you kind of have the idea, it's going to look something like this, whether it's reflected or something like that. We have the cube root function, which looks something like this. Looks very similar to the cubic function, but in a different fashion. So this is the cube root. And we'll talk about why it might take on that property. This one is 1 over x. This one takes on a very particular function. It goes like this, and then it goes like this. And there's actually an asymptote right here. We actually have an asymptote right here, and we'll talk about that more as well later on in the class, that there's a value of x equals 0 that we can never get close to. So as x gets closer and closer to 0 from the right side, you know, you could take out your calculator and do 1 divided by 0.1, 1 divided by 0.01, 1 divided by 0.000001, and the values start becoming larger and larger. And that means that you're getting higher up here. You're getting closer and closer to infinity. Now go from the other way. If you put negative values close to 0, you're going to be diving really far down this way. So that's why this function looks this way, okay? We also have y equals the absolute value of x. We know that this one, okay, let me draw this. This graph looks like the V. So once again, it's good to know, like just when you see an absolute value function, what some of them will look like. So the moment I see an absolute or I see a V on a graph, I start thinking, oh, this might be an absolute value function. This is something that we're going to look into. This is called the, wait, let me write this, absolute value function. Did I write this one down? No, so this is the cube root. Oh man, for some reason the name escapes me of this function. Hold on real quick. Reciprocal function, there you go. So this is called the reciprocal function. And we're gonna deal with quite a bit of problems like that in a later section. I think it's like 4.5 or something like that. Now this one is called the greatest integer function. But I was always taught that it was called the floor function. And you'll see why in a second. Okay. So the floor function basically rounds everything down. Okay. So if you do, you know, f of 1.2, okay, so let's say you had the floor function f of x equals the floor of x. Okay. So that means 1.2 is going to become 1. F of 1.8 is going to become 1. you always round down to the next integer, to the closest integer. So f of 1.99 is going to become 1. Now, f of 2 equals 2, and f of 2.1 equals 2. But then also, f of 2.9 would equal 2. You see how that works? That also means then that f of 0.1 equals 0, f of 0.5 equals 0. So that means, and then what does f of 0 equal? F of 0 equals 0. So that means right here, we put a point right there, okay? And then any value, let's say that that's 1, is going to be right here, okay? But, I messed up. That's 1 right there with an open circle. And let's say that's 1, 2, 3, okay? So now when I get to 1.2, so I go over 1.2, I'm at 1. Let's say that's 2 right there. And then that's an open circle. And then right here, it goes again. Oops. Geez. So these are horizontal lines that end in open circles, so on and so on. Okay, so that's called, some people also call it the step function. Like I said, I was always taught that it was called the floor function because it rounds down to the next integer, to the closest integer. So 1.99 is technically really, really close to 2. But if you have to round downward, then you end up at 1. So that's what causes it to be called the floor function, is it always rounds downward. There's also a ceiling function, but you don't see that as often. I just wanted to kind of give you guys a heads up on all of these. The domain for this one looks weird, but it would actually be negative infinity to positive infinity for this floor function, because even though it hops around, it is a discontinuous graph. It, however, touches every value from the left and from the right, okay? The range is the integers. It can only be an integer. So it will always go all the way left and to the right, but the integers, it never has 1.5 or 1.7. You can never use a height of 1.7 because you always spit out an integer with the greatest integer function, or the floor function, okay? So this is just some information about these. These are kind of the looks. And again, back in the days, you used to have to memorize all these so you could deal with it. Nowadays, you guys can put them in your calculator. Let me see if I can show you. So let me see how long it takes for the calculator to load up. There it is. So all of you should have a graphing calculator for this class. If you don't, you should probably contact the school and see how you can go about getting one. You will need a graphing calculator for this course though. If not, I think there's an online calculator that you can use. It's an emulator like I'm using right here that you can have like a 40-day free trial or something like that. Please contact me if you're having trouble. Okay, so what we're going to do is we're going to go to y equals, and then I'm just going to clear this. And this will just be x squared. No, let's do x cubed. And then I just click graph. Okay, and there you go. That's the x cubed. Now, if we want to graph the absolute value, let me see. I haven't done that one in a while. I think we go into math and then number. Geez, I haven't done this in a while. Oops. Well, we could do let's do a cube root of x. Okay, we just do that and hit enter, and then we graph. For some reason, I can't remember where I found the greatest integer function. This is a little bit different than my calculator, but it should be there. There's the cube root function. So let's see here if I can find it. Let's go math. Nope. Decimal, nope. Not derivatives, summation notation, no. Log base, piecewise, number solver, nope. So I'll have to take a look at this, guys. I don't want to spend a whole bunch of time on this. Oops, I think I found absolute value. Okay, so then we have the absolute value function, and I can say absolute value of x. So I did find that. And then we can graph that, and there you go. Okay, so these are all these things you can plug into your calculator. Just go into y equals. Hopefully you guys have done this quite a bit in the past. If not, it's something we'll have to practice because we're going to use this throughout the semester. But I just wanted to give you guys a little heads up on that. Okay, so these are basically our library of functions. But what I wanted to talk to you guys about mainly today was the piecewise, because I feel like that's the one that most people don't know about, is the piecewise defined functions. Okay, so let's talk about the piecewise defined functions. Okay, so a piecewise defined function is basically, I kind of think of it as like a Frankenstein graph. It's like a bunch of pieces of different graphs that we put together. So the best way I can explain it, and it still has to be a function. So the best way I can explain it is through an example. So let's look at this graph. Okay. And then we say if x is less than 0, if x is equal to 0, and if x is greater than 0. So basically they're telling you which function to use based on what your x values are. So if x was like 7, then we would be using this guy, because here it says that we use that when x is greater than 0. So we use this function x plus 2, which is a line. So basically, when you're asked to graph, you come over here and you do your best to draw a graph. Okay, so now we have x squared. So I'm going to draw x squared. And I know from the idea of it is this, basically, right? From that picture, I know that that's a rough sketch of x squared. That's what a parabola would look like in general. But I want you guys to notice, it says we only care about the parabola when x is less than 0. So that means all of this is gone, and I put an open circle there because they use strictly less than. Remember, less than or greater than, we use open circles, and less than or equal to and greater than or equal, we use dots. We use closed dots, okay? So now I need to graph the other part, x equals 0. So when x equals 0, then we say the height is 2. So that's right here. So I put a closed in dot because notice it says equals, right? So it actually touches. But that's all we do. We don't actually do anything else because they literally are just giving us a point, 0, 2, right? An x value and a height that it would spit out. Now we have to draw the line x plus 2 if x is greater than 0. So now I'm going to do that. That's going to be x greater than 0. X plus 2 is y equals mx plus b, right? So y equals mx plus b. I have y equals x plus 2, so m equals 1 and b equals 2. So I'm going to go up 2 and I'm going to put a dot right there, but there's already a point there. And then I'm going to rise 1 and run 1. So I'm going to rise 1 and run 1, and I'm there. So now I have this line like this, right? I have that line. But we only care about the line at greater than 0. So I'm going to erase all this. So I only care about this part of the line, right? So that's the line that I care about. I don't care about the left-hand side of x plus 2 because they said that we only use this line when x is greater than 0. So they're basically putting restrictions on us. They're putting domain restrictions on when to use certain functions, okay? So what you see on the right now is our piecewise function. So now follow-up questions would be like this. Somebody would follow up and say, okay, so find for the function above, find f of 2, find f of 3, find f of 0, and then maybe f of -7, okay? So what we do is there's only one answer for each. You have to decide which function you use. So when x is 2, which one of these domains talks about x being 2. Well, this domain right here is when, you know, we're talking about 0 or less than 0. So that would be negative numbers. This domain right here is only talking about when you equal 0. And this domain right here is talking about when x is bigger than 0. Well, 2 is bigger than 0, so we use this guy. So I'm going to do 2 plus 2, which is equal to 4. So that would be our answer, okay? Now for 3, that actually would be the same thing. 3 plus 2 equals 5. But now for 0, we now have to think differently. Which one of these has the domain when x is 0? Well, that would be him right there. So we say it's 2. Now, which one of these has the domain when x is negative 7? Well, this one talks about x being smaller than 0, so then we plug negative 7 into here, and we would get negative 7 squared, which is 49. And that's our answer. So this is how you can use a piecewise to evaluate functions. So definitely something you want to practice in the homework. Please, you know, definitely get started on 2.4. It's not a bad section. Again, a lot of what you do with piecewise, you can, or a lot of what you do in this section, you can do with, what's it called? With a calculator. So I don't spend as much time on this as I used to. Back in the days, you literally, when I first started school, like we still had calculators, but they really wanted us to memorize this all the time. And you guys honestly should look at it. And when you see an x squared, you should know that's a parabola. When you see a cubed, you should know that's a cubic function and kind of how it behaves. When you see a square root of x or something similar to that, you should know how it behaves. But I think that's going to be it. This is more of just kind of an easy section for you guys, and just mess with the homework and do the graphs and everything, and I think it'll help. Piecewise functions probably the newest thing, and we can talk about that in the meeting. If you want to try another one, we can go over that in the meeting as well. All right, you guys, that's going to do it for this video. Thanks for watching.